show up or something happen, so at least you will not miss the class and you can see this live session recording. How you access? Yes, please go ahead. Someone wants to say something? Okay. So, if you how you access this recording, so you need to go to this live session here. So you will see like Cisco. So always when you do this, when you click on Cisco WebEx, uh, there you will see your class. In your class, when you click on Cisco WebEx, you will see this thing. And now, if you see this virtual meetings, in this is upcoming session. Here on your side, you will see join, and beside that, you see these past meetings. So when we click here, so far this is our first meeting, so we do not have any recording here. But when we done this class, you will see because it will take some time, it will take few hours for the processing. And after a few hours, you will see this class session, recorded class session, will appear here with the name of the class and the date of the class. Okay, so you will access all previous sessions by into this past meetings. And for live session, always come here and on your side, because I am creating this meeting, I you can see host here, but on your side you might see join only. So you will see join there. Okay, this is one thing. You know that, and you are familiar with the environment of our university, that we do have first 2 weeks attendance. Okay, so I think that I will. How we do this? So let me see. Is there any attendance code? Do you? I don't think so. You will see attendance code module on your site. Attendance. There was attendance. Yeah. Okay. Okay. It looks like it is not required. So we do have recording of this, and I can see from there if it is required. Otherwise, in the course module, uh, there is one quiz when you start. If so, now let me show you, go through with this screen the way I designed this course for you. So we do have class on regular class times every day, Monday to Thursday, first 4 days of a week, uh, from 9:15 to 10:55 a.m. in the morning. The link is the way you join here. So now if you see this second link, this is my office hour link. So whenever you need to join for the office hours, so you will could just click on this. This will again take you to the WebEx, but this will be different WebEx. This will be my private WebEx, and only this class will access this link, and you can come there and you can um, join that session from 11 a.m. to 12 p.m. if it is required. I will always be there from 11 a.m. to 12 p.m. It will be right after this class, after 5 minutes. 11 o'clock, almost 11 o'clock, our class will finish. So then I will start my office hours from morning 11 to 12 p.m. I will log in always as per needed, exactly the way you use physically office hours. So you can come there, you can join. If I will answer your questions. You need to see all these modules start from here, and this will give you all idea of our course modules, syllabus, instructor, my information, and these are 6 weeks. What we will study, I will post the information there. So now my question is, does every one of you have access of chapter 1 and 2? I already posted there. Are you able to see that and download that? So if you go to week 1, I posted here chapter 1 And oh, I did not publish it. So that's why you do not have access of that. Okay. So now you can download this chapter 1 and chapter 2. Okay. So you need to do all these, go through with all this information. Okay. Start here, meet your instructor, all these information. And then you need to do this quiz, orientation quiz. Okay. This will be your kind of your attendance and your um activity. So university required you to do that and do this until you get the complete good points. You will see answers also there when you do this, and this will give you all information. Um, so let me show you the syllabus. So if you see this, the syllabus here, all information is written there. Uh, my classes and timings, everything. So what you will expect in this course? This course names a little bit different. Uh, what what you will get in this course. So this course name shows you that it is a programming languages, and you will do. Initially, the way we conduct this course was just teach a few programming languages like Java or some other language, and then we do the comparison of that. This is not the case here. I'm teaching this course from last almost 3 years. And the first day when I start teaching this course, I am teaching exactly in the same way I designed this course. So we are basically dealing with different mathematical models, different languages. So we try to learn that how we create a language, what are the theoretical aspect of creating a language. So anything when you, so let's say if you want to design a software, so or any database, so it's not that from the day one you start working on the language, and you start working and creating something in any database. So first you need to make a plan that what are the database, what are its fields, what are its requirements, how we will use it, what are its rules and restrictions, who will use it, and what is the each person role of usage in this database, and what is the logic of this work, how the data will flow in in this database. So a lot of theoretical aspect of creating a database. So exactly the same way, when you someone asks you to create a language, so you must first design the theoretical aspect of your language. What is the scope of the language? What are rules and regulations of the language? What syntax is the valid syntax of your language? What syntax is invalid syntax of the language? How many keywords, commands you can provide in this language? So what is the job that this language will serve? So what is the complexity of this language? So all these are theoretical aspects. So you design on paper, and then you will think that then after that, when you design all these things, so then the next step is compiler construction. So you use compiler, and then you write a code and you design your language. So we will not deal with any programming aspect of the language. We will deal with the theoretical aspect of the language, and then we there we will finish this course. Okay, so this is something you should expect in this course. um, I So this course is basically core computer science course, and if from this is the book which I will use. It's a second edition of this guy, Cohen, and this is a textbook. You need to buy this book. I believe that this is very important because if you do not have this book, you will not able to access the end of the chapter. There are some questions, exercises. You will not able to access that. I will provide you assignment. I will provide you questions, But if you are thinking that you want to do some more, you need some more questions for practice, then you need to get this book. Sometimes it is also important that you can read some examples. You need to read the theory to better understanding of this course. So that's why most of the time I do not encourage students to buy any computer science book, because it's so dynamic field that you buy a book and it will change. But this is something which will not change. This is from long time, and it will stay for a long time. This is basically core science. It will not change. Okay. Here you will see course objectives and course learning outcomes and some policies. uh, Please read that. This course will be a very fast paced course. We will finish everything what not in normally we will finish in 4 months. Now we will finish in 6 weeks. So you need to run with me. And you know that this will be a crash course. It will be fast, and I will try my best to go as much slow as possible, but at some stage we need to run because we need to finish the all the course material. Okay, so grading policy is standard. You can see that it is just like the normal policy. So here the way I design this course, I will ask you some quizzes, and the weightage of quizzes is 15%. And then we will have assignments. You will see 40% assignments. And then we will have exam one. So this will be kind of midterm exam. So this will be 20%. And then we have final exam. This will be 25%. So if you see that, and I divide this thing in a way that one area, if you perform not well, it will not destroy your grade. So you still have a chance to improve your grade. So quizzes, you will see around 9, 10 quizzes, number of assignments, exams. Exam will be just like the assignments. If you do your assignments by yourself, exam will be piece of cake. It will be just the another version of the assignments. You will not feel any change in the language. It will be exactly the way I will ask you some questions in assignments. Exactly, I will ask you same way in exam. So idea is that you will not get any surprise that how exam will be. So before exam, you should be familiar with the flavor of questions, the way I should ask, and you will if you so you will see all that flavor in assignments. Exactly, exam will be like that. So the same is the case with the final exam. I do not like to take comprehensive final exam. So whatever the course material you covered till exam one, that will be for your uh, exam one, and then remaining material will be part of final exam. So you can say exam one, exam two, it is like that. So it's not comprehensive exam, it's a half course which you will cover after exam one, that will be part of final exam. uh, these are some topics which we will cover. You will see that I will cover without any leaving any chapter from chapter 1 to 3 till chapter 19 of this book. So it is around 700 to 800 pages. So this will be a huge material which we need to cover. It will never be possible without your help, without your cooperation. So I want you to please attend the class. My experience is that if you attend the class, this will be helpful. You will have chance to ask me a question right away, and I am very much positive that you need to ask me a questions. The way this course material is. If you just rely on the recorded sessions, you can see, you can understand, but you will not able to ask your own questions with me. Okay. So that's it. Now you are free. So please, if you um, want to say anything, so you can uh, share your thoughts. If you are not happy with any course design, or you want to do some changes. The way I design the course, quizzes, assignments, exam, final exam, weightage. So you can share your opinion. All good?
Yeah, all good so far.
Okay. So I see that we have 20 students. So now we have 14 students here. Okay. So 14 students here. Okay, that's good. Okay, so if you are happy with this, so I request all of you one by one. Please, I see your names here, but just give me your introduction. So first, are you from computer science? What is the motivation of taking this course? I know this is mandatory, but again, and what you were, what is your expectation with this course? What do you think that this course will be? And if you are happy with this division of this course, the way I designed this, or you have some concern or some suggestions. So I will ask your name. So Austin, can you please share your thoughts with us and introduce a little bit to other friends? Austin Park, can you please uh, share your thoughts?
Yeah. Hello, my name's Austin. I'm a CS cybersecurity major. I'm taking this course because it's a requirement, but I look forward to learning a lot about programming languages.
Okay. So do you happy with this design? 15%, 40%, 20, 25%?
Yes.
Okay. Gunnar, can you please share your information, your thoughts?
Hello.
Yes, we are hearing you.
Okay. My name is Gunnar Sundberg. I'm a computer science advanced topics major. I'm taking this class. Yeah, it is required, but I'm also interested in computer theory. I hope to learn about the theory of programming languages.
Very nice. Very
And I
nice.
think the grading breakdown looks good.
That's great. Thank you very much. Jacob, can you please share your thoughts? Jacob Sorensen, can you please share your thoughts?
He wrote in the chat that his mic isn't working for him.
Oh, he said that. Oh, mic is not working for me. So did you connect with the mic? Because when you connect with the meeting, it will ask you that which source you choose. You need to choose a source for the mic there. So if you choose that correct source, it should work. And if you are not familiar that what you did, so you can leave this meeting and again join that. So might be that will be this way you can able to do that. Okay. So meantime, it's not working with James Evans,
Hey, can you hear me?
yes, we can hear you.
Okay. My name is James Evans. I'm a computer science major with the concentration of game development in simulation. And the grade breakdown looks good to me. Makes sense.
That's great. James Rodriguez. James Rodriguez, can you please share your thoughts? James, do you hear us? James Rodriguez? Okay, looks like he just here and he he left for something. Jason,
Hello. Hello.
hi.
Hi, I'm Jason Rosky. I'm a computer science major with the concentration of cybersecurity. I'm taking this class also because it's a requirement. And yeah, the grade breakdown, I don't have any problems with it. It looks good.
That's great. Kevin Baker.
Hello, I'm Kevin Baker. I'm computer science, taking this class as a requirement. Um, I also have no issues with the grading scale.
That's great. Thank you very much. Mason. Oh, sorry. Lion. Lion Pena.
Hi, I'm Leon Pena. I'm a CS software engineering major. I'm looking forward to learn more about programming languages, and I'm happy with the grade structure.
That's great. So Mason.
Hello.
Yes.
Hey, I'm Mason. I'm a computer science cybersecurity. I'm excited to learn about programming languages, and uh, weights seem good to me.
That's great. Naban.
Hello,
Yes, we can hear you.
I'm Naban Aziz in cybersecurity, and the weights look fine to me.
That's great. So Nikhil. Nikhil, we cannot hear you. Something wrong with your mic. We can.
There we go.
Okay, here you are.
Yeah, my mic gets really weird sometimes. I need to fix it. I'm Nikhil Pubby. Grading scale looks good. Taking the class because it's required, and I am a CS major with a concentration in game development.
Very nice. Quinton. Okay, his microphone is broken. Science, learning about these general concepts in programming languages seem like a great understanding, making more informed decisions when working with software. I look forward. Very nice. Riley.
Working now?
Yes, now we can hear you.
Hi, my name's Riley. I'm in advanced topics. I'm here because my internship got canceled because of the virus, and the grading scale looks good for me.
Okay, that's great. So most of the time, when for this course, students have this question that why we are doing this. Because so far you need to understand that you are in computer science degree, yes, and this is computer science course. So when we talk about computer science, so some courses are direct courses. So you can, if you learn C language, you will see its direct implementation. You will learn some um some database, you will see its direct implementation. Python, Java, you will see its direct implementation. Mobile applications, how to design a website, it's a direct implementation. But some courses are core courses, core science courses. You will not see, those are the backbone of this computer science. You will not see their direct implementation, but that knowledge is such an important knowledge that partially you will use that knowledge in multiple fields. So this is one of that course. I always have this when these questions in my class, that why we are doing this, what is the practical use of that. At this time your vision is not that much big, but so gradually when you learn some more information of this degree, and you will go to the master program, so there also, and in field you will see this course implementation. Uh, this course is also initially when we have this course, so the only implementation was um compiler construction. So if you want to design your own language, and when you take the compiler construction course, they will not teach you how to design how the rules and regulations of the language, how to design the mathematical models. They will start writing a code, and they will teach you the parsing techniques, lexical analysis, semantic analysis, some other analysis, but bottom up parsing, top down parsing, and some intelligent way of coding. But how you design the machine on which you do this coding, they will not teach you. They expect that you already know that, so that knowledge will come from here. This is one implementation. But as the time is growing, and also I especially use this course in my research in PhD, in computer vision. So I design a language which is non-verbal language, and there I use this course. Whenever when we say that I use this course, it doesn't mean that we use the all knowledge of this course. So some of this I use that and to design the language. And if you let's say if you after this course, after your computer science degree, if you go to any auto industry and you join that, and you are expert of C language, you are expert of Java language, you are expert of Python, let's say, or assembly language, and they said that okay, being a degree person, they expect you that you should have some knowledge of, and they want you to design a small language, and that language will be just perform very few tasks for that robotic industry, for that auto industry. What that task will be, it will hold some part from the from one place, the robotic arm, and hold that part and move the arm up and move towards the left side, and then come towards the down side and drop that part there, or just rotate that part and fix at some part of the car. That's it. So only few commands: holding, moving up, moving towards the left side, coming down and rotate, and that's it, release, and then park, go back from where you start. So now this is again a language, but this language is not doing so much work. It is doing very few restricted jobs. So now you need to design this language. So if you do not know, so there you need this information: how you write the rules and restrictions, how you make sure that the robotic arm will follow all the safety rules, and what jobs robotic arm should never perform, what jobs should it may perform, what in which order robotic arm will perform a job, which job it should always be performed in the first place, and then it will perform that job in the second place, and then it will perform this job. So what are the valid way sequence of the jobs? So all these information you will learn from this course. So this is very important. So most of the time when we do not, because of our we do not have that much exposure, we do not have that much vision, so that's why we do not figure out that how we use this course. But definitely it has a very good use, and you will see this usage in practical field. But this course will complement with other courses. It's not that if you only know this course you will get a job. So you need to know the how to any good programming language, and then some other information, and then this course, and altogether this knowledge will merge, will fuse, and you will create one product, and you can use that course there. Okay, so that's the idea. Just think that you want to create a language, and that language is infinite by nature, and how you write the code or design on the paper mathematical model of that language which is infinite, which it can generate any kind of program, and you how you design that language on paper which is by nature infinite, and you want to design that infinite language in a finite way. So this is very interesting concept. So there you need this course which will tell you that how to capture the languages, how to design the languages, what are the theoretical aspect of that part, and then once you design that on the paper, and then you can do this on the on any by using any language. You can convert that into the any programming, write a code for that, and you can create a language. So it's a very this is the usage of this course. Okay. So now let me go with the modules, and please let me know that you can access. um, okay, rules are this: you are free to ask a question. Do not wait that I will finish and then you can ask a question. No. Wherever you feel that you do not understand, please right away ask the question. Do not wait that I will finish and then you can ask. Okay. You can ask anytime. So this is a rule here. So do not rely on the understanding of your friends. I should be the best source of information for you. Please ask me the question. So your friends are not able to help you in this course. I trust me, they are not able to help you in this course. Okay. So you need to ask, if whatever the questions you have, whatever the confusions you have in your mind, you need to ask me those questions. Okay. Now, all of you, are you able to access chapter 1 and chapter 2 in the modules? So you will not see all these things. This is, I do not post it yet. So you will see only these things. So if you are able to access that, please let me know.
I have access to chapter 1 and chapter 2.
Very nice. Thank you very
Same
much.
here.
Excellent. So let me open this, and so we can. Oh, it is opening here. I think that then I should not open it here. I want to make this maximize the screen, so let me open it. Okay, this is good. So this is first chapter is is kind of theory of this course, that we, so you will see a lot of different names of this course: theory of automata, theory of computation, programming languages. All these are the same. All these are the different names of this course. Different colleges, different universities, they offer this course with these different names. We offer this with programming languages, but some universities offer with theory of automata, theory of computation. All these are the same thing. So when we talk about theory of computers, study of mathematics, so what we are talking about, we are interested in the design of mathematical models. So when you study the mathematical model, so you need to cover these three aspects. What is the abstract information of that? How you simplify that mathematical model, and how you write a code of that. So we will cover these part. So how we the abstract and simplify. We will not do the coding of our mathematical model. This will be your next course. If university offer, this will be your next course. Okay. So mathematical models, which we shall call machines, and then to study their limitations by analyzing the types of inputs on which they operate successfully. The collections of these successful inputs we shall call the language of the machine. So we are saying that, so when we if someone asks us to design a language, so then we need to design a machine here. So this machine is basically a mathematical model of the machine, that which will tell us that what should be the input, what should be the output, and rules here in this machine, how this input will communicate, and then you will validate this this input, that this input is valid or not. And then accordingly, if this is valid, you will provide some output, some response. Okay, so this is the way you, what processing you will do in between. This is called mathematical model. Okay, and we will call this a machine. This is our machine. And this mathematical model, if this is good, if the rules and regulations are good, and whatever the input you provide to this mathematical model, it will give you some output. So then if this is good, there is no problem here. So then we will say that this mathematical model, this design represent one language. Okay, and this language is represented by this mathematical model. It will be exactly like that if we see the meta model of C language. So what are the rules and restrictions of C language? What is the syntax analysis of C language? What inputs you will give? What should be the output? What are the different syntax templates for the C language? What are the different functionalities provided in C language? What maximum you can do in the C language? If you know all that stuff and you design that, how those things communicate with each other. So what are the rules and regulations? How the global variables will communicate, how the local communicate variables will communicate, how the parameters will communicate, how the what is the job of function, what is the job of procedure. So all these things are rules and restrictions for this language. How you write the syntax of the language, and what should be the input and what should be the output. So then if so this design will call a mathematical model, and then it will represent some language. We will say that this mathematical model will represent this language. So now in this course, you will see different mathematical models. Okay, so different mathematical models you will see in this course, based because every mathematical model will have its scope. So some mathematical models are less complex, but they only by using those mathematical models, we are not able to create very complex languages. We are only able to create simple languages, and very straightforward languages. Those languages which cannot perform so much job, only perform very simple job. uh, you want to create just text editor, you want to create just notepad, but then you will see that when you want to create some other language, so those mathematical models will not support that. So then you need to think about some more complex mathematical models, which are more complex and their scope is more big, and by using that you can create some more complex mathematical languages. You want to create your own C++, your own Java language, your own no, any other non-verbal communication language. So you can use that, and then you will see at some stage those mathematical models are not enough, and then you want to use some more complex mathematical models. You want to create your own computer, so you want to create some the design of any computer in your language. So this is some processor, some operating system, something like that. So some big things. So then you will need more complex languages. So basically, this is what we will see, that we will see in the first part of the course different mathematical models, and then in the second part of the course we will see we will write some rules and regulations and the grammar. So now we will see that as the course is evolving, so you will see this all this information in that. Okay. If you have any question in this slide, so let me know. Otherwise, I can go to the next slide. Any question is not a bad question. When you ask a question, you are not helping yourself. Trust me, you are helping other people also. A lot of people like me do not have courage to ask a question. So when someone asks a question, they ask not only his or her question, but us question also, my question also. So this will help me to clear my concepts. So now please, if you ask a question, this will only not good for you, but also some people who are a bit shy, who does not have any courage, little bit courage, less courage, for scared for something. So because we have hesitations, so you will also help them. So please, I always encourage you, ask a question, and do not move. Let me go to the next slide until you are not satisfied, or you have any small confusion in this slide. Okay, we will follow this philosophy that if you I ask you and you do not say anything, I will consider silence as yes, and then I will move forward. Okay, but does not mean that your chance is gone. You can again ask me a question in the office hours, send me email appointment, so I will try my best to help you. Okay, so basic questions. These are some questions which we need to answer. What do theoretical models of a computer look like? What can we compute and what cannot we compute with today's computer as well as computers of the future? Why it is the case? Why we cannot compute? We study some precise answers. So we formulate precise questions with mathematical statements and rigorous proof. So to find those answers, we will see some mathematical models and we will see some proof, and this will you will see that in the coming lectures. Okay. So now this is history. I am less interested in that, but it's better that we should know what's going on. But it is just for the reference. But I mean, you do not need to memorize this. So this course basically is not is uh, we have a lot of concepts we borrow from math, from set theory, from math subjects, from other subjects, and then we have this course. So this course was there long time in 1845, 1980, in some shape, in other courses, and then we need this in computer science. We borrow different concepts from different subjects, and then we make this course. Okay. So now there is a scientist. His name was Cantor. He was the guy who created this theory of sets, union, intersections, cardinality. And then Hilbert, he was the guy who invented the methodology for finding proofs in completeness. So then there is a guy Gödel. So he invented the theorem concept. So then Turing. So which statements have proofs? So building blocks of mathematical algorithms. So then this guy Turing. So he made the universal machine and its limitations. And then this guy neural nets, and this is the guy basically Chomsky, which creates the mathematical model for the description of the language. So we can say that most of the contribution or edge go to this guy who created this course, so Chomsky. So he created this concept that how we design the mathematical models if you for the description of the language. So if you want to create a language which is infinite in nature, how you design a finite mathematical model to describe something which is infinite in nature. So this guy basically he was the guy Chomsky who invented this thing. I do not expect that you memorize all these things. I just want you to remember this guy name because this is more close to us and we have more concern with this guy because he is the person who actually did contribution for which we are studying today. Okay. But I mean, it is good always to know the history of the course. So this is some more description, some more explanation of these people. So Cantor, if you see in this slide, theory of sets, so discovered some very uncomfortable information. So such as idea that infinity. So he came with the idea that infinity come in different sizes. So some sets, which is some, if we have two sets and both sets are infinite sets, one in set is one infinity is that set is small set and the other set is more much bigger than the first set. So he came with this idea. So he said that infinity is comes in different sizes, and later we prove that he is wrong. because infinity is infinity. It comes, all infinity is the same size. We have, when we do not know anything, when something is infinite in nature, so you cannot predict the size of that. So all infinity are the same sizes. So we came with this idea. So then Hilbert, so he wanted methodology that would show how to. So he want to create a mechanism that how we prove something, because to find the proof of something is also a hard thing. So how we, what is a standard way that everyone can follow? If I say that I created this, what is the proof of that? Okay, I said I prove this way. Oh, I don't think so. The way you are saying makes sense to me. Okay, so is there any way that all human beings can standardize the way to prove something? So when someone do or invent something and he prove that, so that method of proving is standard generalized way, so everyone can accept that way of proving, and we can trust that okay, what he's saying makes sense to us because he follow the same method of proving the way we understand. So he want to create the methodology to show and find the proof. So then this guy Gödel, so he said that, so he destroyed everything. He said there was no algorithm to provide proofs for all the true statements in mathematics. He showed that either there were some true statements in mathematics that had no proofs, or else there were some false statements that did have proof. So he of their correctness. So he completely, did upside down all the concepts. He said that might be he showed that actually that some concepts which are right, but we do not have proof of that, and some concepts actually which are wrong, he proved them wrong, and he found that there are proof of correctness of those concepts, and proof says those concepts are right, but actually those concepts are not right. So he came with this idea. So then this guy Turing, he proved that there were mathematically definable fundamental questions about the machine. So some questions, some basic questions, machine itself does not know the answer of that. So then there is another guy. He came with the idea that how the sensory receptor organs in animals behave. So he followed that concept and designed the mathematical model. So then this is something you will see that in our course. There are multiple languages you will define. So these are different mathematical model: regular expression, context free grammar, type 0 grammar. So the scope of regular expression is FA and TG. So you will see all this is basically the summary of whole thing which we will do in you can say in our course. So you will see how we design the regular expressions, and when you write the regular expressions, what are the different machines you can create. You can create FA and TG, and these are non-deterministic. So yes, these are not. So when we say non-deterministic, what does it mean? So there are two concepts. One is deterministic, second is non-deterministic. So when we say deterministic, so it means that there is only one way of doing this. So you have a room. This room has one door. You know that there is only one way to come in this room and to go out from this room. And let's say your room has two doors and you are allowed to come in from both doors, and there are no rules and restrictions. So now this is non-deterministic. We cannot predict that which room you will use to come in. You can come from the room door 1, or you can come from the door 2, or you can go from door 1, or you can go from door 2. So when we have any machine which is deterministic, which can do a job only one way, we like that. Machine does not confuse. Machine knows how to do that because there is only one way of doing this. When there is a machine there and you can do the same thing by multiple ways, more than one way. So we can say that this machine by nature is non-deterministic. You can perform same job more than one way. So that kind of machine is not good. We do not like that. That machine is non-deterministic. And then there is another more discussion which you will see that sometimes we choose that machine which is non-deterministic, and we use some way, we use some method, and convert that non-deterministic machine into deterministic machine. And why we do that, we will see all this discussion in the coming chapters. Okay, and so you can use all these set concepts: union, product, clean star, intersection, complement, and then finiteness, membership problem, and so these are the applications which you can create from regular expression, text editors, sequential circuits, verification. And then you will see some more complicated languages which have more scope, which is context free grammar. So you can create mathematical model, PDA, for that. This is non-deterministic. It is, and you can still use all these set theory there, and you can solve all these problem, and you can create compilers with that. And then you will have type 0 grammar, and you can use Turing machine with that. And the PDA, it is also deterministic. You can still use the same thing, and you can create our current computers are based on the logic we will study in this course. So that's why I'm saying that this is still a current course. So it's not. It's so if you let's choose to go to the hardware side of this course of any field, and there you need to design the circuit boards of the machines. So then how you, before you design the hardware, so you need to design that hardware on the paper as a software, and before you program that, you need to design that program, and to design that you need this course. And then you will start from here, and then you will convert that into programming, and then you will convert that programming into the hardware. So that's the basically thing which you will learn in this course. Any question here? So this is good. I tell you that it's very easy to sleep in this course. So if you have any sleeping disorder or something, you think that, and you are not able to sleep in this course, and if you are able to sleep in this course, you are completely healthy, you are completely okay, no problem. If you are not able to sleep during this course, it means that you should see the doctor. Something is not good, because it's very easy to sleep in this course. So so we try to wake up. uh, did you say non-deterministic languages are undesirable? If so, yes. The thing is, okay, you asked this question. Basically, we have very thorough discussion on this topic in the coming chapters. But as you ask, so I can answer you this question. When your machine is, so being a human being, as a human being, we can make decision that which path is correct, with which path is wrong. Okay, if you have two paths to reach to the same place, as a human being, we can make decision, because human beings are very sophisticated device. We are very sophisticated. Our mind is very sophisticated. We can make decision, and we can do all that math very quickly in our mind, that why we should not choose this path, why we should choose this path, or whichever path is good. But machine is not. Machine rely on human intelligence. So if machine will see that to do the same job there are more than one way, so machine will confuse that which path it will choose. So so then we always try to create a mathematical model which is non-deterministic, but which is deterministic. uh, but the thing is, you will see in coming lectures, that when your machine is non-deterministic, this will make machine very powerful. So when machine is deterministic, it is not powerful. When your machine is non-deterministic, it will become very powerful. So this is something which we want. We want our machine very powerful. But the problem is, if we make machine powerful, machine will be confused how we do this, because there are more than one way of doing the same job. So which way is good? How machine choose that? We do not want human wisdom there. We want machine as an autonomous machine which can decide by itself. So then what we will do, we will create a machine in non-deterministic way, but on top of that, so machine by nature will be non-deterministic, but on top of that we create some rules and regulations. and that way, and some restrictions. So machine, by using those rules and regulations, those restrictions, a machine which will be non-deterministic in nature will behave in a deterministic way. So this is what we will do. So that's the reason that uh, uh, that's the logic behind deterministic and non-deterministic. So Quinton, did I answer your question? Okay, that's great. So that's good. Uh, Now we will see this, and I think that this is again the same thing which I mentioned before, that in this course, all the mathematical models, we will refer them as machines, and all the and what are the languages that machine represent. This will be the language of that machine. So now if you see that I make these slides in a way that I highlighted some information. So this information, and beside some other information, when you read the slides, so this will be helpful for the quizzes. So I try to pop up that information which is important, but still you need to read all the slides word by word to prepare the quizzes. There will be no surprise quiz. I will let you know whenever we will have a quiz, that when we have a quiz and you need to do that quiz, I will let you know that we will have quiz in next class, or which day and which chapters. So most of the time, one or two chapters we will have a quiz. I will not pile up a lot of chapters, and you will see that quiz is there. Okay, so that's the idea behind that. Okay, and here we finish our chapter 1, and that's it. So we finish this chapter, and we finish this thing. So you guys have any questions, so you can ask. Otherwise, we are good.
I don't have any questions.
Okay, that's great. So so let's see the. I think that I should not go to the next chapter. We should start this with a fresh mind tomorrow. And tomorrow we will use our whole time of the class. Because this is the first class, I want you to be familiar with the environment and get settled, and see if you can access the video of this session. And from the next class, we will start this chapter 2, and then we will use this full time. And in between, if you want, we can take 5 minute break, the whichever way you like. But we can continue our class properly. And I don't know if someone is struggling today and he's not able to connect with the class. So just for the first time, for the first class, we will not we will stop here. But from the tomorrow, we will use the full time till 10:55. Your class will finish at 10:55. Okay. So, our quizzes most sometimes, if chapter is really very big, one chapter, but normally I believe that one or two chapters. So it is one or two chapter like that. Okay. So, okay, guys, thank you very much. You now know that how to connect here. Please, tomorrow again, we will have class at 9:15. If you have any question, I will be online 11 to 12 a.m. today for my office hours. You can come there. You will see that link on the main page of our course so where you will see this information. So the link is there. So I can wait there. I will be there, log in. So if you have any questions, you can come there. Buy the book. Getting a book is very important. Okay, so this is very important information. So let me stop recording this. So then I want to share with you some more information. Just a minute, don't go.